An interstellar comet, third after Oumuamua and 2I Borisov. We knew the script by then. Strange trajectory, hyperbolic orbit, data scramble, a brief wave of hysteria, then a long, slow fade into the background noise of astrophysics conferences. We pointed the usual suspects at it. Pan-STARRS, a handful of large, ground-based telescopes, whatever time we could steal on Hubble, and, briefly, Webb. The spectra were odd, but not impossible. The non-gravitational acceleration made people nervous, but we'd seen that movie once before with Oumuamua. Outgassing, weird geometry, maybe some exotic but still natural explanation. That's what we told the public, and mostly ourselves. What we didn't tell anyone was that, from the very first weeks, there were gaps, tiny, precise holes in our observations that shouldn't have been there. Not cloudy nights or maintenance downtime, not power outage in Hawaii or storm over Chile. These were missing minutes in space-based streams. A Mars orbiter that lost lock for exactly 73 seconds, then resumed as if nothing happened. A solar observatory at L1 whose star trackers glitched, but only when their line of sight passed through a specific narrow sector directly opposite 3I's current position relative to the Sun. Every time we tried to triangulate those holes, the same coordinates appeared. A patch of space we had no reason to look at. At first we blamed software. You always blame software. Someone misconfigured time tags, a leap second went sideways, someone's flight code called the wrong table. But the logs refused to cooperate with that story. The outages weren't random. They came in a rhythm synced to 3I Atlas's position, like an echo in our own data. When 3I was here, the gaps appeared there, not ahead of it, not behind it, but mirrored across the Sun, as if something invisible were tracing its orbit from the opposite side. We called it a conjugate pointing anomaly in the internal report. Naming things makes them feel less like nightmares and more like bullet points. The senior staff skimmed it, raised a few dry questions about instrument calibration, and moved on. We, the ones stuck with the raw feeds, didn't. We started overlaying the outages on solar system maps, adding layers, GPS timing glitches, DSN carrier phase noise, tiny shifts in TDRSS relay latency. If you blurred your eyes enough, it looked like static. If you stared too long, you saw something worse, a ghost orbit matching 3I's path, drawn not in light but in missing information. The first time we used the word mirror, it was a joke. Someone dropped a crude sketch of the solar system in the shared chat, mirrored 3I across the Sun, and wrote, "Here's where your bug lives." People reacted with the usual emojis, the cathartic humor of overworked scientists at 2 a.m., but the more we checked, the less funny it became. The phantom coordinates from all those unrelated systems didn't just sit roughly opposite 3I. They sat precisely on the trajectory you'd get if you took its orbit, inverted it through the Sun, and let gravity do the rest. Same inclination, same eccentricity, same inbound leg, only on the other side of the star, like a second runner on a hidden track. We tried to observe that region directly, of course. Point some eyes at it, see if reality cared enough to show us anything. A few of the big scopes allocated us pity time. Half an hour here, a short sequence there. CCD frames came back the way you'd expect. Stars, cosmic rays, a faint smear of background galaxies, no obvious new object, no bright intruder, nothing you could circle in red and put on a slide, but buried deep in the noise, in the readout of detectors that should have been boring, something was off. Dark current fluctuated just a little more than thermal models allowed. Star images twitched by a fraction of a pixel in one direction only, as if the entire field were being tugged through a transparent viscous medium. We argued about instrument systematics until our throats were dry. I sat through meeting after meeting where people half my age lectured me about flat fielding and subpixel registration, like I hadn't lived through the Hubble spherical aberration fiasco and the James Webb deployment anxiety. I let them. Partly because they were not wrong, we could be fooling ourselves, and partly because the alternative was admitting we'd stumbled onto something we had no language for. We are trained to distrust symmetry when it appears in noisy data. Symmetry is what our pattern-hungry brains impose on the chaos, not what the universe kindly offers us. And then GPS went weird. You didn't hear about that part, at least not as the real story. The public got a bland note about temporary regional disruptions due to ionospheric disturbances, and some hand-wavy mention of solar activity. There was solar activity that week, which made the lie easier to swallow. What actually happened was nastier, in a band of longitudes whose local midnight lined up with the mirrored sector of 3I Atlas's orbit. Civilian GPS receivers began to disagree with each other in strange ways. Phones in the same street reported positions tens of meters apart. Survey-grade equipment, the kind that usually gives you centimeter-level accuracy, insisted that fixed benchmarks were creeping slowly across the landscape at a few centimeters per second, then snapping back. If it had been just that, a little position drift, some glitchy cars on map apps, we might have shrugged it off. But we had one more layer of data most people don't: the raw timing solutions. GPS is, at its core, a global clock masquerading as a navigation system. When we dug into those timing residuals, we found that the errors weren't random. Satellite signals arriving from a specific wedge of sky were consistently early by a handful of nanoseconds, as though the path between them and the receivers had shrunk in a way that didn't map cleanly onto atmospheric models or relativity corrections. We projected those problematic lines of sight out into space. They crossed inevitably in the same invisible corridor opposite 3i Atlas. That was when my boss stopped telling me to get some sleep and started closing his office door when I walked in. There is a tone people adopt when they are both terrified and professionally obligated to weigh odds in public. Flat, carefully neutral, every sentence polished until all personal pronouns and adjectives have been sanded away. He used that tone when he said, "We are not authorized to use the word object until we have photons." So we chased photons. We begged and traded for time on anything we could point: optical, infrared, radio. We spun up VLBI baselines that hadn't been used in years, trying to see if an invisible mass was lensing background quasars as it glided along its mirrored path. The results came back maddeningly close to null. No sharp lensing events, no double images. But when we stacked months of data and subtracted every known systematic, what remained was a whisper, a slight, statistically insolent dip in flux from sources that, by all familiar laws, should have been constant. Something was passing between us and the distant universe, but it was more absence than presence, eaten light rather than reflected. Maybe it's simply dust, someone said in one of the telecons, clinging to the word like a life raft. A faint, diffuse tail that happens to be aligned? Dust doesn't eat timing, I snapped, harsher than I meant to. Dust doesn't make your satellites decide their clocks are wrong only when they look at one very specific patch of sky. We went quiet after that. Somewhere, thousands of kilometers away, I heard someone on the call clear their throat, the tiny crackle of an unmuted mic, betraying a human behind all the pretty plots and acronyms. The term mirror orbit slipped into our internal lexicon without anyone officially coining it. It's how we started to distinguish between the thing we could see, 3i Atlas itself growing slowly from a magnitude bleeding speck into a resolved coma, and the thing we sensed only by its effects. We would say, 3i hits perihelion at this epoch, mirror at this. Or, if the mirror continues to track, the anomaly sector will cross over this ground track in 6 months. Saying it that way, casually, made it feel like a reasonable extension of celestial mechanics instead of a violation of its spirit. By the time the first points appeared on Earth, I had already stopped thinking of the mirrored sector as just a region of the sky. It felt more like a shadow sweeping over the planet, invisible, but not inactive. The word points came from the incident reports, concise and desperate, written by engineers who had never expected their tidy Newtonian world to behave like a corrupt video game. The earliest one that crossed my desk involved a weather balloon over the Pacific. Mid-flight, its instruments reported something impossible, a drop in altitude of 50 meters without any corresponding change in pressure. For 18 seconds, it was as if the balloon fell through space that did not agree with the air around it. The GPS track showed a jagged spike. Then, just as abruptly, everything went back to normal. The telemetry log, played back later, had a gap, exactly matching the time when the balloon floated beneath the mirrored sky that could have been shrugged off as a radio glitch. But then came the others. A self-driving test car in Nevada refused to follow a perfectly painted lane, insisting that the road abruptly veered a meter to the left at a specific stretch. LiDAR, camera, radar, every sensor swore the same thing. When engineers overlaid the trajectories from dozens of runs, they found a reproducible kink in the perceived geometry of the world, localized to a patch no larger than a living room, like a polygon in a virtual environment that had been dragged out of alignment. A surveyor in Ukraine reported that his laser rangefinder would, at certain coordinates, measure the same distance between two concrete pillars as both exactly 10 meters and 10 meters plus 47 centimeters, depending on whether he took the reading just before or just after local midnight. His instruments weren't drifting. The discrepancy snapped on and off like a switch. In each case, when we projected the location and time into the celestial sphere, the same uncomfortable truth emerged. Overhead, or rather underfoot if you extended the line all the way through Earth, lay the mirrored track of 3 Atlas's orbit, carving its ghostly path through space on the far side of the sun. We were walking through the interference pattern of something that should not have had a partner to interfere with in the first place. You learn, in this business, not to fall in love with your own explanations. Confirmation bias is a more reliable constant than the speed of light, so we fought ourselves every step of the way, asking whether we were stacking coincidences until they formed a monster, but the monster kept obligingly growing new limbs. Power grid oscillations subtly shifting phase along long-haul lines only when thunderstorms rolled under the mirrored sector. Marine navigation systems reporting phantom shoals that vanished as soon as the sky rotated enough to move the overhead point away. Sometimes, late and alone, I would pull up the simulation we'd built. The sun in the center, Earth and its siblings humming along, 3i Atlas threading in on its steep, uncaring hyperbolic arc. Then I'd click the option that almost no one outside our little circle knew existed, the one labeled Mirror. A second path would appear, pale and translucent, carving a perfectly symmetric trajectory on the opposite side of the star. No object plotted, no mass assigned, just a line, like a shadow of a shadow. Watching the two arcs converge inward toward the inner system, I always felt the same cold thought settle in my chest. Whatever was riding that hidden track had had a long time to learn how to use symmetry better than we did. We didn't know yet what it wanted. We only knew that as 3i Atlas fell closer toward the sun, the universe was starting to behave as if reality itself had to negotiate between two incompatible versions of where things should be. We found out what it wanted by accident, which is the worst way to learn anything dangerous, because it means it was ready for us long before we were ready for it. The trigger wasn't a big collider or a billion-dollar probe, not some grand experiment specifically designed to tug at the fabric of space. It was a stupid, routine calibration pass of a navigation satellite, one of hundreds in a constellation whose name you know, but whose individual serial numbers you never will. That satellite, tagged ID-147 in our internal logs, happened to cross directly through one of the points over the Atlantic at the exact moment the mirrored sector peaked overhead, and unlike balloons or cars, it carried instruments precise enough to tell us that reality didn't just wobble there, it forked. Telemetry from ID-147 came down as two separate data streams that should not have been able to coexist. One set of packets reported a perfectly normal orbit, with position and velocity vectors that matched our predictions to within a hair. The other, timestamped with the same microsecond accurate clock, insisted that for exactly 2.3 seconds the satellite had been several kilometers off track, trailing a trajectory that diverged slightly inward, closer to the sun, before snapping back as if nothing had happened. There was no interruption in power, no radiation spike, no mechanical error. It was as if, for those 2 seconds, the universe had entertained two incompatible solutions to the same equation and, instead of picking one, sent us both. On the review floor, the engineers stared at the dual tracks plotted on the big screen, two colored lines overlapping almost perfectly except for that brief split. Someone made the obvious joke about glitches in the Matrix, and nervous laughter rippled through the room. Too loud, too forced, but the joke stuck in my mind for another reason. In a simulation, you can save state, try one branch, roll back, try another. In physics, or in the version of physics I grew up trusting, you don't get that luxury. Except now it looked like we might be living inside something that had just tried exactly that. The obvious question was whether the divergence was purely mathematical or whether anything physical had come along for the ride in that forked path. The satellite's attitude control logs gave us a hint that made my stomach twist. For those 2.3 seconds, its reaction wheels had quietly spun up as if fighting a torque that didn't exist in the normal track. The star tracker, which logs the apparent positions of reference stars, recorded tiny shifts consistent with being in a slightly different gravitational potential. ID-147 had tasted the other version of where it could have been, and some part of it had resisted the transition. We ran the numbers once, twice, 100 times. We cross-checked clocks against ground stations not affected by the mirrored sector. We dug through every conceivable failure mode. Each time we stripped away the noise, the structure remained. A clean, symmetric deviation, precisely aligned with the passing of the mirror orbit overhead. I remember sitting back in my chair, feeling the old naive comfort of stable orbits finally give way. Whatever was on that hidden track wasn't just causing jitter, it was inviting local patches of spacetime to briefly consider its preferred geometry, and our machines were dutiful enough to report both options before collapsing back into the one we recognized as real. There is a point at which you stop asking, "Is this happening?" and start asking, how much of it can we let happen before something breaks we can't fix? The ID-147 event forced us over that line. Suddenly, the mirror wasn't just an abstract ghost orbit, it was a player in our domain, capable of creating transient branches of reality in which objects actually move differently. We had to assume that, if conditions were right, those branches might not always snap back so cleanly. A satellite rejoining its original timeline was unsettling. A passenger plane or a section of power grid getting stuck in a misaligned patch was unthinkable. We proposed, in dry language and carefully hedged bullet points, limiting operations in regions where the mirrored sector crossed Earth at critical times. Temporary procedural restrictions. We called them as if we were talking about closing an airlane for weather. The pushback was immediate and brutal. You can't just tell airlines that certain latitudes are less real during specific orbital alignments. You can't tell shipping companies, internet backbones, and entire countries that their sky periodically becomes a bad idea. There was no way to enforce it without admitting, publicly, that we thought chunks of the world were flickering between different versions of themselves when no one was looking. So we did what humans always do when faced with a threat that attacks the abstractions we live on. We pushed the risk one layer down, out of sight. The guidance that finally left our hands and went out to operators was watered down into recommendations about avoiding firmware updates, time-critical maneuvers, and high-precision measurements during the following windows. It read like a generic space weather bulletin, the kind that gets filed and ignored unless something already goes wrong. We hoped, quietly and without much conviction, that it would be enough to at least minimize the number of systems that might be caught mid-operation if another branch event occurred. While the bureaucracy did its slow dance, the anomalies on the ground kept getting stranger. The points multiplied, though most were still so subtle that only obsessive field engineers and unlucky surveyors noticed them. A train control system in Japan logged a single instant where two independent wheel sensors disagreed about whether a high-speed carriage had passed a track junction. Security footage later showed a barely perceptible stutter in the motion blur, like a single misplaced frame. In a lab in Germany, an atomic clock experiment recorded a tiny, sharp deviation in frequency exactly when the mirrored path crossed overhead, then dutifully averaged it away over the next few hours, as if embarrassed by its moment of disobedience. What haunted me wasn't the glitches themselves, but their pattern. Every one of them lined up with our model of the mirror orbit, a model we had built from our own data. It felt like drawing a monster on the wall and then watching the shadows peel themselves off to match the outline. We had, by mapping the interference, given shape to something that might otherwise have remained diffused and harmless. Now it was behaving as if it owned that shape. Of course, there were those who saw opportunity where I saw only risk. In closed-door sessions, I wish I had never attended. People with sharper suits and duller souls than mine began to ask a different kind of question. If the mirror could make reality try out alternate configurations, could we learn to steer those forks? Could we, by modulating our own signals or mass distributions at the right times, bias the outcome toward branches we found beneficial? Imagine, one of them said with a smile that didn't touch his eyes, being able to nudge a satellite into a slightly better orbit without propellant, or shift a storm track by altering how the atmosphere responds in the negotiation phase. To them, the universe glitching like a buggy simulator was not a horror, but a feature request. I remember staring at the rising stack of proposals and white papers, each more confident than the last, all built on the same arrogant premise that because we had noticed the mirror and given it a name, we were in a position to collaborate with it. As if the thing on the other side of the sun had been patiently carving symmetric grooves through space-time for eons, in the hope that one day a primate civilization would come along and offer to co-author the patch notes. We were still arguing about ethics and feasibility when 3i Atlas reached the inner edge of the giant planet region, and something changed in a way even the most stubborn skeptic couldn't shrug off. Up until then, the mirror had been subtle, working its will through timing shifts and tiny geometrical lies. But as 3i crossed a certain threshold in its descent toward the sun, the nature of the anomaly shifted from gentle persuasion to something closer to assertion. I noticed it first in the star tracker logs. These instruments, mounted on everything from crude capsules to weather satellites, look at the pattern of stars to figure out which way up is. Their software is robust, designed to cope with missing stars, cosmic rays, lens flares. But now they started to report constellations that didn't exist, not random nonsense, coherent, repeating arrangements, triangles where there should have been quadrilaterals, slight rotations of familiar asterisms into unfamiliar geometries. When we overlaid those impossible constellations on our mirror model, they matched what the sky would look like if you were observing it from a point not where the satellite actually was, but where its mirrored counterpart would be. For a few seconds at a time, scattered across the fleet, our machines were seeing the universe from the wrong side of the sun. It's hard to explain the visceral wrongness of watching that happen. Even if you haven't spent your life trusting star catalogs the way sailors once trusted lighthouses, it meant the mirror wasn't just tugging at paths or shaving nanoseconds. It was offering alternate frames of reference and seeing which ones our systems would accept. It was teaching our devices to hold, however briefly, two maps of reality in memory at once. If you've ever debugged a program with conflicting coordinate systems, you know how quickly that kind of ambiguity can cascade into nonsense. Now imagine that happening not in some simulation, but in the instruments that keep spacecraft pointed, planes on course, and indirectly, economies running. I started seeing ghost images everywhere after that, even when I wasn't in front of a console. A reflection in a window that didn't quite match my movement. A GPS route on my car's display that flickered for a moment as if considering a road that wasn't there, then correcting. Intellectually, I knew I was primed to notice coincidences, that my brain was doing what human brains do best, weaving patterns into noise. But knowing didn't help. The more data we pulled in, the more it looked like the mirror was no longer content to be an abstract adversary at infinity. It was extending feelers into everyday life, looking for systems flexible enough to accommodate its preferred symmetry. We convened one last, all-hands analysis session before 3i Atlas crossed the orbit of Mars. Representatives from space agencies, military branches, telecoms, even a few shell-shocked people from the aviation sector dialed in. The agenda was, officially, to review current evidence and update risk assessments. Unofficially, everyone was waiting for someone else to say the thing aloud, that we were approaching a point of no return. If the strength of the mirror's influence scaled with 3i's proximity, then whatever we had seen so far might just be the prelude. I walked them through the evidence as calmly as I could, my voice detached and dry, even as my palms sweated onto the notes. The paired orbit, the timing anomalies, the ID 147 fork, the ground points where geometry tore like cheap texture maps. The star trackers that briefly saw an entire sky from the wrong vantage point. I watched faces on the screen go from skeptical to tight-lipped, then to the flat stillness of people mentally updating their personal lists of what they had believed was impossible. When I finished, there was a long silence, the heavy kind, full of people waiting to see who would dare to move first. Finally, someone from the European side unmuted, their accent clipped and precise. "So what you are saying," they said, "is that our reality is now in a kind of negotiation with an unobserved frame, and that negotiation will intensify as the interstellar object approaches perihelion." "That's one way of putting it," I replied. "And is there," they asked, "any plausible scenario in which this negotiation fails?" I thought of the double path of ID 147, of the way the branch snapped back into our version of history, because this time nothing locked it in place. I thought of the proposed experiments to push systems during mirror passes to see if we could gain leverage. I thought of the ghost constellations and the world that for a few seconds at a time was tempted to be somewhere else. "Yes," I said finally, "there is a scenario where the negotiation fails. That would be the one where the alternate frame becomes energetically or structurally preferable for enough local systems that the mirror's solution, not ours, becomes the default in those regions. At that point, from our perspective, those regions would behave as if they'd slipped. Slipped where?" someone else asked. I looked down at the simulation still running on my personal screen, the twin arcs curving inward toward the sun, drawing closer with every tick of the clock. It was a stupid, inadequate visual. The true geometry was higher dimensional and cruel. But sometimes, to understand horror, you need the simplest picture. "Into the other side of the orbit," I said. "Into the version of the solar system where the mirror object is the one that's real and we are the ghost." In the weeks that followed that call, the phrase "slipped regions" migrated from a theoretical phrase in one meeting to a quiet, unspoken assumption in every other. No one wrote it into official documents, but you could feel it hanging behind every line that mentioned localized instability or frame-dependent anomalies. We started to build maps, not just of where the mirror sector would be overhead, but of where the world had already tried, however briefly, to be somewhere else. At first the dots were scattered and isolated, a test range here, a patch of ocean there, a stretch of rural highway where a surveyor's instruments had misbehaved. Then, as 3i Atlas descended past the orbital distance of Mars, the pattern changed. The dots began to cluster. The first cluster that scared everyone was over water, which is probably the only reason you never saw footage of it on the news. A chain of autonomous buoys in the South Atlantic, part of a long-standing oceanographic array, reported a series of events that our models had told us to expect only in the abstract. For 31 seconds, 9 separate buoys all disagreed about the height of the same wave that passed through them. Not just by a little, by meters. One buoy measured a perfectly mundane swell, another a spiking wall of water that should have capsized a ship. A third reported nothing at all, as if the surface had gone glass smooth. When we overlaid their positions against time, the pattern looked like a rippling zipper. Reality trying on several different surface configurations, and then hastily stitching them back into one. There were no ships in that sector at that moment, which was either luck or evidence that someone, somewhere, had taken our recommendations more seriously than they admitted, but the buoys themselves were changed. 2 of them came back online with corrupted firmware images that, when examined in the lab, showed binary differences, mimicking exactly the phase of the mirror orbit overhead. Bits flipped not at random, but along a repeating, mirrored pattern. as if the devices had been exposed to an alternate version of their own software and half adopted it. The code still ran. It just wasn't strictly the code we had written anymore. It was around then that the first stories started leaking to the public in their distorted, humanized form. Glitch storms trended on social media for a few days, clusters of videos showing GPS maps spinning, compasses wandering, drone footage freezing for a handful of frames, and then resuming at a slightly shifted angle. People did what people always do, turned fear into entertainment. Compilation channels added synth music and dramatic captions. In comment sections, conspiracy theorists and bored teenagers debated whether we were in a simulation, whether CERN had broken reality, whether angels were tilting the earth. I watched those videos at 3 in the morning with the sound off, tracing timestamps and star fields, and confirmed what none of those viewers could know. Every glitch storm took place under the mirrored sector's sweep. Inside the agencies, things grew tense in a different way. Departments that had barely tolerated each other were suddenly forced into sharing data. Space weather, cybersecurity, deep space tracking, aviation safety. Everyone suspected that someone else was hiding the worst anomalies in a private vault. Everyone was probably right. I started getting messages from people I hadn't spoken to in years, old colleagues and former students now embedded in corners of the machine I barely understood. Their notes followed the same pattern. Off the record, are you seeing X? Do you know if anyone is correlating Y with Three Eyes Ephemeris? Is it possible for a satellite to be in 2 states at once? I wanted to tell them no, to recite the catechism of classical physics that had soothed generations before mine. But we were long past the point where that catechism matched our observations. So instead, I did the only honest thing left. I sent them fragments of our mirror maps, anonymized and stripped of coordinates, and let them draw their own conclusions. Some wrote back with gratitude, some with anger. A few didn't write back at all, which worried me more than either. 3i Atlas itself, meanwhile, had become almost banal in its behavior, at least in the frequencies the public could see. It brightened in a slow, stately way as it approached, its coma expanding, its tail unfurling in the familiar choreography of dust and gas responding to solar radiation. Telescopes produced beautiful composites, all teal haze and needle-fine tails against star fields. Popular science outlets ran explainers about interstellar chemistry, about how each new spectrum line told us something about the cradle of some distant star. All of that was true. In a narrow sense, the comet was giving us a gift of alien ice and dust. But to us, watching the hidden twin orbit like a ghostly reflection, the visible beauty felt like a distraction. The real story was unfolding at the edges of what our instruments could admit they believed. The first human incident happened over in northern Canada, on a night so clear you could see a ribbon of aurora stretched like green silk across the sky. A regional jet, flying a routine path, reported a brief loss of all external references. From the cockpit's perspective, the stars went out. Not dimmed, not clouded, extinguished. For 4.7 seconds, every window showed blackness, interrupted only by the faint, ghostly glow of the instrument panel. Then, just as quickly, the sky came back, but wrong. The co-pilot's testimony, recorded later in a voice made calm by shock, is one I can still recite by heart. The constellations were folded, he said, like someone had taken the sky and pushed the edges toward the middle. Orion's belt wasn't straight anymore. Polaris was in the wrong place. And the horizon? He stopped there in the recording, breathing audibly before forcing himself to continue. The horizon wasn't where the instrument said it should be. For maybe a second I thought we were upside down. Then it snapped. The stars jumped. Everything was back. Almost turned out to mean that their inertial navigation system and the GPS disagreed by several kilometers for the next 10 minutes, even though both appeared internally healthy. It took delicate work from air traffic control to guide the plane back onto a verified path. No one on board was hurt. The passengers, most of them asleep, remembered only a slight turbulence, and some of them a vivid sense of having dreamed something they couldn't quite put into words, a feeling of falling sideways, through a world whose edges didn't line up. When we pulled the raw star tracker data from the aircraft systems, my earlier dread was confirmed. For those few seconds, the pattern of stars in its sensors matched exactly the simulated sky from a point along the mirror orbit, a few million kilometers displaced from the plane's actual position. The aircraft, for the briefest moment, had navigated by a sky that belonged to the wrong side of the sun. After that, the word slip stopped being taboo in internal memos. We had our first clear case of a macroscopic, inhabited system flirting with a branch of reality that did not belong to it. And if it could happen once, in a controlled, recoverable way, it could also happen in ways we weren't capable of steering. As 3i drew nearer, the mirror's trace over Earth stopped looking like a wandering line and more like a slowly tightening net. Every day the ground track shifted, covering new latitudes, new cities, new infrastructure. We watched it sweep over undersea cables, over megacities fat with electronic nervous systems, over deserts where only a few outdated satellites would notice if the sky twitched. We tried to get ahead of it, scheduling critical operations away from the worst windows, but there is only so much you can do when the thing you are fleeing is not a storm or a flare, but a moving argument about what position even means. Some nights, exhausted and too wired to sleep, I would imagine what the mirror object must see, if see is even the right word for whatever mode of awareness something like that might have. From its point of view, perhaps, the solar system had always been twin-layered. One version where the luminous comet we called 3I Atlas rode its path in ice and light. Another where an unlit, unseen counterpart glided in perfect synchrony, unbeaten by photons. Maybe the anomalies we experienced were not attacks, but side effects. The transient interference fringes of two valid solutions being forced for the first time to overlap in the same small, noisy region. Us. That thought was almost comforting compared to the alternative, that the mirror was not some passive twin, but an instrument, a tool designed by forces unknown to enforce symmetry where none existed before. There is an old temptation in physics to treat conservation laws as well polite abstractions, tidy bookkeeping rules the universe follows because it likes order. But what if, at scales and energies we had never probed, those laws were less like preferences and more like mandates, enforced by systems we would be right to call machines? And what if one such machine had just entered our neighborhood, insisting that everything, from satellite orbits to local geometries, conform not to our messy, accreted history, but to its own idea of a balanced configuration? When 3I Atlas finally crossed the orbit of Mars and fell inward toward Jupiter, the simulations began to diverge. Some models said the mirror's influence would peak and then fall off as the geometry changed. Others predicted a runaway, a feedback loop in which each small, successful correction of reality made the next one easier. We had no data from prior events. Oumuamua and Borisov had been too small, too fast, or perhaps too alone. There was no record in the ice cores or crater catalogs of a previous mirror event of this scale, unless it had been so thorough that it left nothing of the prior configuration to compare. In the end, the universe chose not to consult our models. It simply moved forward. The first true slip region, the one we all agree on, the one we mark as the beginning of the second ephemeris in our private notes, occurred not in some far-off ocean or polar plateau, but in a perfectly ordinary industrial park outside a mid-sized European city. There was nothing special about the place. A cluster of low buildings, a substation, a tangle of distribution lines, and fiber trunks. The only reason we noticed that what happened there with such clarity was that one of those buildings housed a timing lab. Racks of ultra-stable clocks, lasers, and optical fibers used to synchronize everything from stock exchanges to scientific instruments. For 12.4 seconds, according to their logs, the lab existed in two states. In one, the one their staff remember inhabiting, the lights flickered, a few instruments briefly lost lock, and a technician cursed as his terminal rebooted. In the other, reconstructed from the branch of data that should not have existed, the power never blinked. Instead, the clocks advanced an extra microsecond that could not be reconciled with any known drift. The two timelines rejoined so cleanly afterward that most of the world never felt a thing. But in the data, in the merciless, high-resolution trace of phase and frequency, you can see the fork and the merge like a scar. It was only later, when people started combing through security camera archives from neighboring buildings, that we realized something worse had happened. In one camera's footage, a delivery truck passes the lab at exactly 09:17:03, its logo clearly visible. In another, viewing the same stretch of road from a different angle, the truck passes at 09:17:03 as well, but the logo is subtly, undeniably different. Same colors, same layout, but the company name has an extra letter, one that does not exist in any registry, any database, any memory of the humans who work there. The plates are off by one character. The driver wears the same jacket, the same face, but his ID badge shows a photo where, in our records, there should be another. It was a small thing, laughably small compared to the apocalyptic fantasies some of us had imagined. A truck with the wrong logo, a handful of microseconds, a set of clocks that had lived through both outcomes and quietly averaged them away. But standing in the lab a week later, listening to the hum of the racks, I could not shake the feeling that we were walking on the seam between two versions of the world, and that the mirror, patient and indifferent, was still pulling. I started to notice the seam everywhere after that, not because reality was coming apart in spectacular ways, but because the subtle mistakes had become impossible to unsee. A road sign in a town I knew well suddenly showing a distance that was off by half a kilometer, even though the GPS coordinates still matched the old value. A colleague's email history containing a message I distinctly remembered drafting but never sending. now sitting in his archive stamped with a date that didn't match my own outbox. You could rationalize each one individually, misprints, misclicks, bad memory, but together, against the backdrop of our mirror maps, they built a quieter horror. We were accumulating artifacts from branches that were not supposed to leave any fossils behind. The official line hardened into a sort of nervous denial. Publicly, 3i Atlas was a triumph of coordinated astronomy, the subject of glossy animations and breathless documentaries about our third interstellar visitor. Privately, the same agencies that filmed those documentaries were quietly rewriting operational procedures to include phrases like frame stability advisory and geometry integrity window, bureaucratic euphemisms for times and places where we have reason to believe the world is more likely to be itself. That's the part the public never grasps about institutional fear. It very rarely looks like screaming. Most of the time it looks like new forms, new acronyms, new checklists. I spent more and more of my time in a windowless room, deep beneath a campus that looked from the outside like any other research facility in any other quiet city. They had moved our mirror group there for security reasons, which everyone understood to mean so that when something truly frightening happens, you are already in a bunker. The room was dominated by 3 displays. The first showed the evolving orbit of 3i Atlas in classical ephemeris form. Distance, velocity, angle, all numbers we could still pretend to understand. The second showed the mirror track, a pale arc tightening around the sun in perfect counterpoint. The third showed Earth, wrapped in a shifting mesh of colored bands and dots, predicted slip windows in one color, confirmed anomalies in another, the timing and metrology scars glinting like static. On good days, we convinced ourselves that we were mapping the perimeter of a storm, that by charting where the fabric had already creased, we could predict where it might fold next. On bad days, it felt like all we were doing was drawing more precisely the outline of something that had already decided where it was going to land. Either way, the maps kept filling in. The second, true slip region did not announce itself with glitches or aircraft incidents. It announced itself with silence. At exactly 14:03:17 UTC on a Wednesday, a cluster of ground-based telescopes in Chile, Hawaii, and the Canary Islands all lost the sky. Not locally. The cameras were fine, the domes intact, but cosmically. For 9.6 seconds, every star brighter than a certain magnitude simply ceased to register on their detectors. The faint background galaxies remained, smeared across the CCDs like ghosts. The Milky Way was gone. When the stars came back, there were differences. The differences were small, subtle, buried in astrometric residuals and photometric curves, a tiny shift in the apparent position of a nearby red dwarf, a slight change in the brightness of a Cepheid variable that had been stable for as long as we'd recorded it. Only when we triangulated those changes across multiple sites did the true shape of the slip emerge. The sky that returned was not quite the same sky. It was a version offset by fractions of an arcsecond, as if the entire local universe had been re-registered against a slightly different coordinate frame. The public explanation, when it finally trickled out weeks later, spoke of a rare synchronization of instrumental artifacts and atmospheric phenomena. It was a phrase that meant nothing and everything, designed to pacify anyone who needed to hear that the people in charge had a name for the thing. Inside our room, we called it what it felt like, a global frame comet. For a few heartbeats, the mirror's preferred solution had dominated the negotiation, and when the two frames merged again, the compromise favored its geometry. You might think such a change would have immediate, catastrophic consequences. It did not. Planets still orbited, apples still fell down, your coffee still obeyed the cup. But the more precisely we measured, the more we saw that our reference anchors, the fixed points we used to define where and when we are, had been nudged. This was not a disaster in the cinematic sense. It was worse. It was the sort of slow, deep structural alteration that only matters if you intend to do careful science, maintain a global technological civilization, or insist that your reality be internally consistent. Unfortunately, we were very invested in all three. The accusation started then. Some whispered, some shouted. One camp insisted that we had caused the escalation by observing it, by building models, by naming it a mirror orbit, as if baptizing it into our language had somehow given it purchase on our world. Another argued that our attempts at mitigation, the operational advisories, the quiet reshuffling of schedules, had inadvertently synchronized human systems in ways that made them easier for the mirror to flip wholesale. A few, leaning hard into an old superstition dressed in new terms, claimed we had invited it by daring to treat conservation laws as negotiable. I didn't have the energy for blame. My guilt took a different shape. There is an unspoken promise in my line of work that when the universe does something strange, we will at least have the decency to understand it, to translate awe into equations and fear into forecast plots. Standing in that underground room, watching our maps light up with every new slip report, I realized we had already broken that promise. We were no longer explaining, we were documenting. Archivists at the end of a geometry we no longer controlled. Sleep, when it came in jagged fragments. In my dreams, I walked through cities I knew, but the details were wrong in ways only someone who had studied coordinates for decades would notice. A familiar avenue bowed gently where it should have been straight. The clock tower at the Institute stood a little closer to the river. Shadows fell just a few degrees off from where the sun's path had to be. No monsters leapt from the dark. No catastrophic fissures opened under my feet. It was just the wrong world, wearing my memories like a borrowed coat. The worst part was the feeling upon waking that the wrongness in the dream had been easier to accept than the precarious correctness of the world I returned to. As 3D Atlas approached Jupiter's distance, the mirror's influence reached a new regime. Our models had warned us that something would happen around that point, where the gravitational interplay between star, planets, and interstellar visitor created a labyrinth of potential trajectories. The mirror, it seemed, had been waiting for that complexity. It began to use the giant planet as an anchor. We saw it first in the timing of Jovian radio emissions. Jupiter's magnetosphere is a noisy, wondrous thing, throwing off radio waves in bursts modulated by its rotation and by the dance of its moons. We have decades of records, a library of how that chaos should sound. Now, the bursts arrived early on one rotation, late on the next, as if Jupiter itself were briefly considering spinning a little faster or slower, then deciding against it. The effect was tiny, buried deep beneath the storm of ordinary variability, but it was there, correlated perfectly with 3I's position and, more ominously, with the predicted path of the mirror object as it swung in to share Jupiter's orbital neighborhood from the far side. The idea that the mirror might lock onto Jupiter the way it had begun to lock onto our smaller system sent a fresh chill through the community. If the negotiation of frames could extend from satellites and city blocks to a gas giant, what would a slipped Jupiter look like? A world with slightly different mass distribution, slightly altered spin, slightly tweaked moon orbits. It wouldn't tear the solar system apart overnight, but over years, decades, the knock-on effects would ripple outward. Tides, resonances, asteroid belt dynamics. The entire long-term choreography of the system would no longer be the one written in our fossil record of craters and orbits, but a new script authored in part by something that did not evolve here. It was around then that some of my colleagues proposed the only response that felt, to them, proportionate, to create our own mirror. Not a physical object, and we had neither the time nor the technology to launch a counter comet, but an artificial symmetry in information. If the mirror's power lay in enforcing a balanced configuration between visible and unseen, perhaps we could confuse it, or at least localize its influence, by flooding space with competing symmetries. The plan, insane and brilliant in equal measure, was codenamed Janus. It called for every transmitter within reach, from ground stations to communication satellites to deep space probes, to broadcast paired signals, twin versions of the same data, offset in time and frequency according to a pattern calculated to mimic the geometry of a hypothetical anti-mirror orbit. The hope was that, by presenting the universe with a more complex symmetry to conserve, we might force the negotiation of frames to favor outcomes closer to our current configuration. In less charitable terms, we would be gaslighting reality, telling it that there were more twins than there really were, and daring it to decide which ones deserved to be real. I argued against Janus at first, not because I had a better alternative, but because every instinct screamed that introducing more ambiguity into a system already struggling with overlapping solutions was asking for, well, not disaster, because disaster implies an end. Something worse, an indefinitely prolonged state of indecision, a universe forever between branches. But fear and caution do not sit well against plots showing Jupiter's spin curve wobbling. The decision was made above my pay grade, as such decisions always are. One day, my screen showed only the quiet ballet of natural signals. The next, the spectrum filled with echoes. The effects were immediate and unnerving. In the hours after Janus came online, the rate of small, localized anomalies dropped. GPS tracks stabilized. Surveyors reported fewer impossible readings. For a brief, dangerous moment, it looked like we had outsmarted the mirror. Papers were drafted, embargoed press releases prepared in case the stabilization held. I watched my colleagues' shoulders relax, watched their faces regain that thin layer of professional arrogance that says, we face the unknown and bent it to our will. Then the first multi-branch event occurred, and any illusion of control evaporated. It happened in a city whose name doesn't matter, because it could have been any city wired tightly enough into the global grid. For 0.8 seconds, according to phone logs, traffic cameras, and ATM records, there existed 3 mutually inconsistent versions of a single busy intersection. In one, Captured on the primary municipal feed, the light stayed red, and cars idled patiently. In another, recorded by a privately owned camera on a nearby storefront and later retrieved, the same light turned green and traffic flowed. In a third, visible in a fragment of compressed video uploaded to a social media server in a branch of the network we almost missed, the intersection was empty, devoid of vehicles, bathed in an odd grayish light that did not match the weather in either of the other two. When the frames rejoined, if rejoined is even the right word for what followed, the city systems agreed on one outcome: the red light branch. No accident occurred, no pedestrians were harmed, to most inhabitants nothing at all happened, but the data from the other two branches did not vanish. It persisted in caches and buffers, in backup systems and uploaded snippets like ghosts that refused to dissolve. For the first time, we had unequivocal digital evidence that the universe had not just tried out different configurations and erased the losers. It had kept them, however briefly, as if some higher level process were now archiving possibilities. Janus hadn't stopped the mirror. It had taught it how to handle more than one twin at once.